All right, Matt, you're good to go.
Uh, Hello, everyone, and welcome to the HeatSmart Southern Tier program. My name is Matthew Tilley, and I'm one of the Energy Corps interns for the Network for Sustainable Tomorrow. Today, you are going to learn about air source heat pumps to determine if they are right for your home. Next slide. So I want to quickly mention that our virtual webinar series for 2021 is going to be coming out in the near future, so stay tuned for that. And thank you to everyone who has been a part of our 2020 virtual webinar series. Next slide. So HeatSmart Southern Tier program is a program part of NEST. NEST is a nonprofit organization that is funded by the uh, New York State Energy Research Development Authority, also known as NYSERDA. We work towards generating social, environmental, and economic well-being in the greater Binghamton area. Next slide. Today we're going to talk about our program and some of its value propositions. Then we are going to dive into air source heat pumps and have a live walkthrough of a home with air source heat pumps deployed. After that, we will get into money, how you can participate, and then finish off with a Q&A. Next slide. So we are one of 15 HeatSmart programs existing across New York State. These community outreach programs are all funded by NYSERDA, and the programs help to provide local experts with a third-party viewpoint of these technologies and what the process entails for deploying them in one's home. Next slide. So some of the top-level benefits from these technologies include reducing energy costs, both in the short term and long term, improving the comfort of your home, and reducing climate change. It is ideal that everyone becomes energy literate as of now, not only because some of us will be working in that industry, but because we will eventually need to replace our existing transportation and manufacturing energy systems. And what better way to do so than with clean energy? Next slide. So this visual here provides a good idea of what the major contributors to greenhouse gases are in New York State. The main one is transportation, but heating and cooling for buildings is close behind it. Following that is electricity, then waste, and industry. New York State is focused on the greening of electricity, but as you can see, that is not the main problem. It would be good if we incorporated electricity into all aspects of buildings and transportation, and we already understand how electric and hybrid electric vehicles function. But in terms of buildings, there has not been a breakthrough for electric heating with heat pumps. Next slide. So these are the technologies that our HeatSmart Southern Tier program covers. We have weatherization, which is home insulation and air sealing, and then ground and air source heat pumps and heat pump hot water heaters. Next slide. So our installer partners are all competitively selected by by us with the help of NYSERDA through a request for proposals process. And these are our partners that we have decided on currently. For air source heat pumps, we have Air Source LLC for Broome, Tioga, and Chenango counties, and D&D Refrigeration for Delaware County. Ground source heat pumps, we have Daily Geothermal, and then for our insulation partner, we have the Insulation Man. Next slide. So I am now going to pass it to one of our installer partners, Dave Tierno for Air Source LLC, who's going to give you a live walkthrough of one of our homes that has air source heat pumps deployed.
All right, how's it going, folks? Thanks for joining. What we have here is, this is a basic, let me get my glasses, a diagram of, I'm on the phone, so I can't see very well. Diagram of a refrigeration cycle. So basically you have a hot side and a cold side. The evaporator absorbs heat from the air by way of the evaporation of the liquid refrigerant turning into a gas. So as that liquid evaporates in the evaporator, it absorbs heat from the air And then that gaseous refrigerant gets sucked into the compressor. Compressor squeezes that gas, which increases the temperature of it. That's a very key part of it. Everyone says, how can you make heat from 10-degree air? Well, that's how. You absorb the energy through evaporation. You raise the temperature by compression. And then the hot gas goes into the indoor unit in the house, where it's circulated through a heat exchanger. A fan moves the air across that heat exchanger, thereby cooling the hot gas to a liquid, where it goes back out to the evaporator, evaporates into a gas, gets squeezed, increases the temperature of it, blows off in the condenser inside, and it's just a continuous cycle there. Next slide. Types of heat pumps. Well, the only type of heat pump we're concerned about today is air source heat pumps, but the ground source uses basically the temperature of the earth to heat a liquid glycol solution, because the earth is a pretty constant temperature throughout all the seasons. You don't need as advanced of refrigeration equipment to absorb heat from that, because you're not dealing with colder temperatures. You're dealing with, anywhere from 20 to 40-degree water typically. So it's just a closed loop. Typically there are open loop systems, but most systems are closed loop, whether it be it horizontal loops or wells, where the water is circulated through, and that goes into a centralized heat pump system inside the house, which distributes it to the ductwork or to the piping, whatever type of distribution system it is. Heat pump water heater is the same as the previous slide. It's just absorbing heat from the basement area. So, if you have a semi-finished basement, that's a good fit for you. It will cool the surrounding area, depending on how much load and how much you're running that heat pump. The more you run it, the more heat it will absorb from the air. The air source heat pump, it's pretty simple, just goes outside and uses an advanced refrigeration cycle to pull heat from the air, transfer it into the house, or it's as easy as a push of a button. It has a reversing valve and it pulls heat from the inside and puts it outside. That would be air conditioning mode. Next slide. So here, this is a picture of a few installations. On the left-hand side, that's a whole house installation that we did in Erieville, New York, on a log cabin. I think that was 7 zones, I think, possibly, each with its own independent control. And then there's some various methods of distribution there. The wall mount, which a lot of people are familiar with. The ceiling cassettes, which we do a lot of now, they fit actually in between joists. So they can go on a first floor, second floor. The mini duct that you see there, that's nothing you would see. That's actually typically in an attic above a ceiling. It's called a ceiling concealed unit. And that can catch, 4 or 5 rooms and save a lot of money by reducing the amount of zones that the system needs. It also helps from a design standpoint. When you have a lot of rooms with smaller loads, it helps you collect all those loads onto one zone, which is a much better way to design the system. You want to design around the load, not around the number of zones desired. So next slide. Benefits of air source heat pumps. Energy savings, obviously. You're going to save a lot of money on your heating compared to delivered fuels. It's also pairs very well with solar, which is a great way to be sustainable and cut your cost. I have a lot of customers with new builds that put in solar with the air source heat pump, and of course their investment covers their cost of operation. Air conditioning and heat without ductwork or any other type of distribution. Some people have electric baseboard or no centralized system, and it's a perfect solution for that because it heats, it cools, and it doesn't need distribution. You can do part of a home. You don't need to do the whole house, where some of the other solutions are you can only do it for the whole house. You wouldn't do it for just 1 or 2 rooms. So that's the flexibility of it. You can put it anywhere. The different types of delivery methods, depending on the configuration of the house, ceiling, floor, high wall, low wall, ducted. There's just a million different ways to apply it to get the most optimal solution for the customer. Each zone is independent, so you can heat different rooms to different temperatures. Not where you have a duct system. It's one thermostat and you set it for what it is, and every room is basically subject to the design of the ductwork. It's like when you want water at the kitchen faucet, you turn the faucet on, all the faucets in the house don't come on. You only want the water where you want it, what you need when you need it, basically. They're quiet, and there's another benefit on here that's not on here, and that's, there's no combustion. So you don't have to worry about a chimney. You don't have to worry about carbon monoxide. You don't have to worry about, can the fuel truck get to my house? And there's a bunch more, but that's a pretty good overview. Next slide.
So at this moment, Dave Tierno is going to take us through a live video tour of air source heat pump system that he put on himself. So Dave, if you'd like to turn your camera on, we can see that, please.
Okay. Give me just a second here. Switch. There we go. I'm here in the mechanical room right now. How's that? You can see that pretty good, right?
Yep.
So what this is, this style system we put in, this is called a branch box style system. Not all whole house systems we do are this style. I would say most of them are, but not always. It's not always the best solution. In this case, it was. So what this is basically a junction box. You have the outdoor unit outside that's collecting the heat, and that outdoor unit, which I'm going to go show you in just a minute, it feeds the heating and cooling in through these main. I'm up. Really? How's that? Is that better?
You can see it fine.
I guess I was upside down. So these pipes here, this delivers the heat to this branch box, and each one of these is a zone. And this is the refrigerant is metered individually to each one of these zones to deliver heating and cooling to the inside of the house, which we'll go see. I'm going to go outside real briefly. So this is the outdoor unit. This right now, this has the air, outside air blowing across this coil. You can see these, this is copper fins and aluminum tubing. So in here is the liquid refrigerant. The air is blowing across it and it's boiling that refrigerant. So it's this 25 degrees out here, the air coming out of the front, after it gives up its heat to the refrigerant, this refrigerant in here, this liquid is boiling. And as it evaporates, it absorbs heat from the air. Air coming out this side is 10 degrees colder than what's going in. So that's where you've gained the energy. You can see it's very, very quiet. There is a compressor in here that's actually running. And as it runs, it's squeezing the gas, increasing the temperature of it. And then it sends it back into that branch box to be distributed throughout the house. So we're going to go take a look around the house. Gotta grab my mask. Okay, so here's a finished basement area. You see a zone there. Up we go. Okay. Isn't it beautiful? We had the privilege to work in this amazing house. So this is one zone here. This is a low wall unit that carries the majority of the heating load for this section of the house, which is, hey, Sonny. So this is a pretty big, great room with high ceilings. And the source of heat is right here. Works great. In here, here's a master. And there's another low wall unit there. So we go upstairs. This is a big timber frame house, as you can see. Here's a unit here. This unit is in the loft. Hi, Martha. So this unit overlooks this. And this is actually handles the majority of the cooling. And then we'll do, these bedrooms are identical. They're basically mirror images of each other. So we'll just go into one. And this would be Evelyn's room. Hi, Evelyn. How are you today? Good. Evelyn's unit is here. This is her lovely little room. She's got some nice decorations here. She loves that. She can have her own temperature in here. She likes it much cooler than her brother in the other room. Come on, Sonny. Okay. Back downstairs. That's basically the tour. You want to go to the next slide?
Yeah. All right. Thank you, Dave.
Yeah.
Let me just reshare the PowerPoint.
Oh, you are, okay. I'll let them know that.
And go ahead, Dave.
Oh, I'm sorry, I didn't mute myself. Oops. Jeff is available for questions unless we have, oh, we got a few more slides to go through. That's right. Hang on. Incentives, financing. Okay, yep. So basically this just covers the available incentives from regarding New York State clean heat and your electric utilities right now. So if you want to go ahead to the next slide. Oh, geez, I need my glasses for this. Okay, so yeah, these are the basic incentives. I'll talk about the air source heat pump because I'm intimately familiar with it. I've been doing this for a long time. Pretty much what we do, 80% of what we do is whole house. We've been specializing in that for years. And our whole house customers get, it's based on how many BTUs the system makes at 5 degrees Fahrenheit. So for every 10,000 BTUs the system makes at 5 degrees, there's a $1,000, it's called a rebate here, which is a little misleading. The customer doesn't have to put the money out and get a rebate. It's basically taken right off the top of the proposal. So if it's a $18,000 project and it's a $5,000 incentive, the customer just pays the 13, and the contractor is responsible for getting that. Contractor is responsible for getting that to getting that money for themselves. So it's not up to the customer. It's completely on the contractor. The water heaters, everything else is self-explanatory. The $500 per outdoor on a partial load, basically that's we do them, and we just basically give that $500 to our customer. It says there's $100 per outdoor for the contractor that they're, allowed to keep for themselves. We just donate that to the project. So basically, even if you're doing a single zone, there is a $500 incentive that comes off the top for that application. Next slide. Financing. This is a really, really good loan. We actually worked with NYSERDA directly on the very first Green New York loan for air source heat pumps in the state. And we've done a lot of them. We were happy to help them out. They do an amazing job in really getting people connected with this technology. I support them in any way I can, every opportunity I get. The smart energy loan, we do a lot of those, 5, 10, or 15 years at 3.49 or 6.99%. Most in our area are qualified for 3.49 based on location. There are other financial qualifiers based on income, but most of what I've seen, most people qualify for the lower 3.49 if you use auto pay for 5, 10, or 15 years, and there's no penalty for early payoff. The on-bill recovery is a little more involved, but and we haven't found the necessity or to use that. We haven't had anyone very that interested in it. Most people just go ahead and do the smart energy loan. And this new companion loan is really exciting because there was a cap for 25,000, and now that the Air Source is kind of teaming up with the energy efficiency. You know, a lot of times the projects may go over what that allotted amount. Now there's a companion loan available so someone that wants to do a deep energy retrofit and an air source heat pump system, they can kind of pair those loans together. So that's a really, really great thing for people. So, and then of course there's some private, you know, type of financing options as well. But next slide. Process. Yeah, I mean, basically, you know, you sign up for an assessment, and that would be done through the insulation man. You know, first and foremost, it's your best bet to always, you know, do what you can to tighten up your house and insulate your house prior to us applying a system. I mean, a lot of times during our assessment in a house, you know, I do this all the time. We go in a house. We're talking about one this morning, one in the attic. You know, there's very little insulation up there. So I recommend, hey, people to call the insulation man, have them get their audit and have them get the insulation improvements done first. It really helps minimize the cost of the system that we install. And it also minimizes the operation cost of the system. So basically make the load as small as you can practically. It's not like you're going to rip all your walls down and start from scratch, but basically they'll give you a comprehensive list of things that you can do to make those improvements and, you know, do the low hanging fruit. And then, you know, then we can apply the system. It's just more practical that way, and it's more cost efficient. So you'll get the assessment. We'll go to the house. We'll measure the house, the windows, the doors, look at the insulation system. We'll do a load calculation. We'll design a system, and that leads to us being able to provide a proposal. We'll send a proposal. You know, the customer just reviews it. If they want to move forward, then at that time, then that's when you would, you know, apply for incentives or financing if necessary. And then we just schedule the work. It is noteworthy. If you're on a municipal electric or a co-op of sorts, you're not eligible for the incentives. You need to pay the service benefits charge. Some of you may be familiar with that on your NYSEG bill, the SB charge there. That's what funds this. So if you are a municipal, unfortunately, there's not, these incentives aren't available, but there is, you can check with your municipality because there's an IEEP that can hook you up with some pretty good rebates. So depending on what municipality, you know, I don't know specifics of which one does which, but if you call your provider, your municipal provider, they will be able to help you out with that. Next slide.
So now we will go into a little Q&A. If you have any questions for Jeff or for Dave or for my team and I, please feel free to write it in the chat or unmute yourself.
And Olivia, if you can advance, there you go. So there's a bunch of questions that came in earlier. I'll go backwards here. Talk more about how the mini duct in the attic works, Dave. And I'll just remind
sure.
folks that Jeff, the homeowner, is also available to answer questions in addition to Dave. Go ahead.
Yep, and Jeff is also very, very knowledgeable when it comes to home performance and this particular system. As far as the mini duct goes, it's a small air handler, if you will. It has a coil in it. We mount it in the attic. How does it work? Basically, the refrigerant is fed directly to that coil. We build a plenum, and that distributes it to each room that we decide to condition. So the project we're doing now, the whole house project we're doing, it's mostly a lofted area, but there's 2 bedrooms and a large laundry bath upstairs. So we're ducting it to 3 rooms there. So the benefit to that is normally the smallest wall unit you make would be like a 6,000 BTU unit. Well, the loads in those rooms aren't anywhere near that. So you have three rooms on the smaller side, small loads. So we can put a 9,000 BTU mini ducted unit up in the attic and let that unit handle all 3 of those rooms. Helps the system run more continuously, and it saves a lot of cost. It's already a 6-zone system, so we're saving 2 extra zones. It would be an 8-zone system, would add a lot more cost of hardware to the project. So it's better from a design standpoint. It's better from a cost standpoint. You have to be, they're low static. They're not meant to overcome a lot of restriction in the ductwork. But if you understand the equipment and how to apply it, and your ductwork is 100% airtight and insulated properly, they're a great solution. So
Dave, we're getting a black screen for you right now. I don't know if your phone is down or something.
Oh, hang on. I know. Duh. How's that?
There we go. Much better. Okay, so question from Jerry. Talk about annual maintenance costs.
That's a good question because they're not always an annual maintenance item. The biggest maintenance that you have to worry about is the indoor units. They will get a buildup inside after using them, especially for air conditioning. If you use them all the time for AC, depends on the customer, depends on the house, depends on the exposure of the unit. There's a lot of variables, but most of my customers, there are some that need maintenance every year, but most are probably, I would say, in the 3 to 4 year range, or 2 to 3 year range, 2 to 4, somewhere in there, due to that buildup. Because you've got a dark area, you have organic matter floating around in the air, so dampness, organic matter, and cool, that can lead to things that you don't want growing inside your AC unit. But like I said, it's variable. So I train my customers how to notice, how to inspect their unit to say, when does it need to be cleaned. The really important thing about this is Mitsubishi has just come out with a new coating for their systems, for their indoor units, which reduces that by 10-fold. So that was one of the major, points of input and feedback they got from their contractors is, they do load up after, everybody's does. It's physics, it's science, that's what's going to happen. So they were able to design a special coating that really minimizes that and reduces maintenance cost by 80 to 90%. So where before maybe you would need it every year, then now every 10 years, from what they're saying, how effective it is. So, and I think that's coming this year, that those units with that coating will be available. So great question, Jerry.
And Dave, when there is a visit necessary, what's the cost like?
When it's a unit, a lot of times we visit and there's units that don't need to be cleaned. When the unit does need to be cleaned, we have a very, very thorough process for cleaning that unit, cleaning the fan, cleaning the coil, cleaning the drain, checking the outdoor unit. It's typically about $150 a zone for a residential. Commercial stuff is more because that can get pretty gnarly in the commercial environment, and restaurants and so on and so forth.
So I'm going to jump ahead to a follow-up question. Can the new Mitsubishi coating be applied to existing units?
I don't think so. No, it's not. It's applied to every little nook and cranny of the coil. There's just no way to do that. It's probably a pretty involved process.
And was the air source heat pump running during the tour?
Oh yeah. Yeah, of course. Yeah. I went outside and it was running while I was standing next to it. So they're pretty quiet.
Great. If you already have ducting from an existing forced air system, does that lower the cost of installation?
I'll tell you, they do have equipment designed to tie into existing ductwork. I'm not a fan. It's not my thing. Ductwork typically that I see is not properly designed. And it's not insulated. It's not sealed. A lot of times it goes up inside walls where you can't get to it. And when you're going from something like fuel oil to an air source heat pump, you really need to understand the system, and the temperature of the supply air is going to be lower. If it's 5 below zero out, the temperature coming out of the heat pump is going to be lower than what's coming out of an oil furnace. So because of that, you really need to move more air. And being that most ductwork systems are undersized in a lot of ways anyway, it can be problematic. Yes, you can do it. It's not the ideal solution. It doesn't give you the ability to zone. You still have ductwork that traps dirt. It's more noisy, so on and so forth. Can you do it? Yes. If you had like a really good ductwork system and we could just come in, put an air handler underneath it, yes, it could save you some money, but you'd lose out on a lot of the benefits. And I really don't think that using existing ductwork, I mean, for the broad majority of the time, it's not going to give you as an effective solution, certainly as ductless. But
so Stephen has another question. The short answer I'll give: yes, you can use a system for heating and not for cooling. But Dave, maybe you could talk about the costs and benefits of cooling offered by heat pumps as opposed to conventional air conditioners.
sure, yeah, I mean, there's no comparison from an efficiency standpoint, but also mostly from a comfort standpoint. It's way less to run. I mean, everybody knows that, and it's quiet, and it's and all of those things. But the ability of the system to modulate down so low and run fairly continuously, it's always removing moisture from the air. So you get this steady, you can look at the condensate drain and it's just a steady little drip, you know, where central air or central air, the thing comes on, it blasts air for 5 or 10 minutes because they're usually oversized by contractors. It satisfies the thermostat, it shuts off and leaves you with this like cold, clammy feeling. So the continuous nature, the system's ability to modulate down and constantly cool gives you this wonderfully dry, cool feeling where you don't, where before maybe you'd set your AC at 70, now you're at 73, just because it's a more dry, comfortable feeling. So it's far superior in every way to any other AC that I've ever experienced.
So we don't have any other questions in the chat, but I was thinking maybe we could ask Jeff to come on and give whether there are ever observations he'd like to give.
Excellent
about
idea.
the process, what it was like, and in terms of the front end and sort of the whole process and how he's feeling about it now.
Sure, can everybody hear me?
Not very well. You're breaking up pretty badly. You might want to use, oh, there we go. Yeah. No, I'm afraid your reception wherever you are is bad.
Hang on, Jeff.
Yeah, I need another Wi-Fi emitter. Dave, I'm going to come.
Okay.
And Dave, you're probably not able to pay attention to this, but I'll just mention that there's a couple other questions in the chat, and I can read one whenever you like.
Okay, here's Jeff for an overview.
Hi, folks. As far as an overview, like Dave said, I had some pretty good familiarity with this type of technology, so it was easy for me to take the leap of faith. When I built the house, as you can imagine, the budget gets tight coming down the stretch. We actually only put in one single unit on the south end of the wall, the big end of the wall that you saw with all the windows. And we had direct vent propane gas heaters on the first floor for supplemental heat. That system, as minimal as that is, worked pretty darn good. And we got by for a decade with that. And we had a smaller system cooling the whole house. Did a fairly good job. Didn't really reach quite into the bedrooms, especially with door closed, as you could imagine. And it took care of a lot of the heating work. It kept the upstairs warm. Again, the kids' rooms would fall off a little with their doors closed, but it wasn't a problem. When we got to the point of really finishing the house out here a year and a half ago, we got started. There was no question for me what we would do to properly and really effectively heat and cool the whole house. So Dave put in a 5-zone new system, and we moved the existing unit down into the lower floor that you see is still in the process of being finished. That's the room he walked through first. We moved the existing unit down there, which is kind of cool. It gives us independent control over the two systems. I'm not sure if he mentioned, but my system, it either all heats or all cools. But with my independent system downstairs, I can do either. It's not tied to the rest. So it kind of works good in transition times of year where I might be wanting heat in one area or cooling in the other. It's very quiet. I can't say enough about how satisfied we are with it. Immediate improvement on the building structure. I had some minor condensation on the windows in really, really cold outdoor temperatures, like in the teens or below. That's now gone. The back of the house, obviously is the house is now balanced. We had imbalance because we were heating and cooling from a single location basically throughout the house. The house is well insulated, so that is what allowed us to get by with that kind of a system. But since we upgraded, there's no question. I am absolutely ecstatic. It was an immediate impact, and it's just a really comfortable house to be in. So I'm very, very satisfied and happy with it.
Thanks, Jeff. There's another question in the chat here. Can you mix mini duct and outdoor units?
I'll let you rifle that one.
Mix mini duct and outdoor units. I guess I'm not sure what that question is exactly. The mini duct you can use a mini duct now as a single zone system, or you can use it as part of a multi-zone system. So the mini duct can be utilized pretty much for any application, but it doesn't matter what the outdoor unit is per se. But it can be used in a single zone or multi-zone. Hopefully that's a helpful answer.
I might be divining some of this. The functions of these two things are necessary, both of them, for any system. Mini duct is one version of a distribution point.
Yes.
So at one point we had a slide up, maybe you could bring that up, Olivia, of a number of different ways in which distribution gets done in terms of the units, the interior units. It's the exterior units that have the heat pumps. Right, that's what actually takes the air and turns it into heat through the process of the refrigeration process that Dave described. And yeah, go ahead.
It's two components. You have an outdoor unit and you have an indoor unit. The outdoor unit does the work of collecting or rejecting the heat, and the indoor units do the delivery. So here on this slide on the left-hand side, those are outdoor units that are the workhorses. That's where the compression takes place. Where the phase change takes place. And then on the right-hand side, those are all different ways of delivering the heating or cooling to your house. So think of it this way to simplify it. The outdoor unit makes the heat, the indoor unit delivers it. So think about the indoor units as a substitute for a hot water baseboard, or for a vent in the wall, or so on and so forth. So hopefully that clarifies it. But yeah, we have different units that go in the ceiling. That mini duct goes, like I said, that goes up in the attic, and then all you see in the ceiling is a diffuser. The low wall units are just like during the tour, I showed you a few of those. This house, we have low wall and high wall units. And the high wall units, pretty much everybody's familiar with those by now. So hopefully that helps clarify.
The high wall unit is the one that's referred to as a wall mount in this picture.
Yes.
We don't have any other questions in the chat. I would really encourage other folks to either do that or just make a note, say unmute, and we'll unmute you. In the meanwhile, just a couple of things from me. One is the start of the process. If you're interested in getting your own home assessed, which is really where you get answers that are specific to your property as opposed to Jeff's property or some other property, you just go to the web link that I posted a couple of times in the chat. If you don't remember all that or you can't copy it, just go to nynest.org. And basically, Dave will contact you, schedule time to come out. That's free. Another thing that I wanted to share, I was just on our monthly NYSERDA call. NYSERDA, as was mentioned, funds us. And they've been working in the process to get more HVAC contractors that don't install heat pumps to do that. And one of the pieces of information that I thought worth sharing is that a lot of conventional HVAC installers don't actually know much about what current technologies can do, either on air source or ground source. So there's a perception in terms of not being able to heat evenly or adequately and so forth. And so what often happens is, every homeowner has to have a relationship with some sort of HVAC contractor, right? To make sure that your system is maintained. And if you have an outage or what have you, never mind installing a new system. And often you'll get that sort of advice, and that sort of advice, unfortunately, is not accurate. So I just wanted to encourage folks who have relationships with contractors to not necessarily take that as gospel. get a second opinion, get Dr. Dave or one of our other partners to come in and diagnose your house for you, assess your house, and you can find out what the deal is for you. And Jerry, I would echo. Jerry says we're fortunate to have an air source heat pump installer as competent as Dave Tierno in the Southern Tier. And I see another question come in. I will say this, that there's an art and the science to what Dave does. The ability to do a good job in sizing and designing and installing a heat pump is a more complex matter than a conventional furnace. That's, the way they operate is very different. Conventional furnace is usually either off or it's on. The heat pump operates at a lower temperature. It can be on all the time or barely on or on full. It heats and it cools using a different technology. It's important that the house be well insulated. The conventional heating system is kind of a blunt instrument. You can put one in there, often they're oversized just to make sure it's warm enough. And so it is a little bit more complex. Not that it's rocket science. What we're trying to do is get more people into the business, but it's very important to have quality installation. So Dave, there's a question here.
Yeah, I saw it.
You got it?
From
Okay.
Tom? From Tom?
Yep. Yeah, you should read it though, because then people will know what the question is when you answer it. Or I can.
Oh, you'll go ahead. It's not on my screen now.
Okay. I installed a ductless system mainly to replace my cold stove for heating in April of 2019. The system works well for cooling, but I'm very disappointed in it for heating. Too drafty, too noisy, and too costly to run. Ended up restarting the coal. Any advice? Well, I know one question that Dave's going to have is tell him about what the system is and who put it in at some point. Maybe not here, but go ahead, Dave.
Yeah. So it's unfortunate, but a lot of this comes down to the design, understanding what you're trying to do. What's the load calculation? What did the contractor do a load calculation? How did he size the system? What equipment did he use? I see all the time, temperature, air source heat pump equipment that's not designed for low ambient operation, trying to be used, for a source of heat when the output drops dramatically, as the temperature drops. The stuff we put in here, this has 100% output at 5 degrees Fahrenheit still. And the newer stuff is now 100% at 5 below zero. So it takes a really a thorough understanding of the equipment, of the house, not just the house and what the load is, but is there anything that needs to be done to improve the situation of the house so that air source is an effective solution. I mean, I've walked into houses and you sit down and you talk. It's a plank built house. There's no insulation. There's the wind blows. The curtains move and all that kind of thing. And told people, it's just not the right, solution. When you have, tremendous loads, you're better off investing in improving your house and then applying it effectively. So I can tell you, knock on wood, in all my years, I've been basically specializing in this for about a decade now. I don't have any customers that are dissatisfied. We take the work very seriously. We try to understand as much as we possibly can about every facet of the equipment of the house. There's a million things to consider. I would say that you have an improperly applied piece of equipment, possibly an improperly selected piece of equipment. There's a lot of guys out there that go in there and say, well, yeah, we'll put a 2-ton in there. And, it's just not. I just did one in Binghamton that, someone went in there, they're going to put this enormous 2-ton air handler on this wall of this little bitty room. And I went around, I did a quick load calc. I showed the people, look, here's your load is 8,000 BTUs and they're putting in 24,000. It's going to cycle on and off. It's going to cost you more to run. It's enormous. It's going to take up half your wall, so you have better aesthetics, better performance, better dehumidification, just from having a basic understanding of how to apply the equipment, what equipment to use, and how to understand a load and how to calculate that load. So there's a lot of stories out there like that. We get calls to fix, other companies' stuff. Nobody's perfect. We certainly aren't. We try to be. But the point is it's really all about you want to get a company in there that understands the equipment, is passionate about it. And I understand NYSERDA wants to encourage more people to get into it, but what you don't want is a whole bunch of people getting into something to make money. That's the wrong. People need to get into it for the right reason. So if you're hiring someone, you want them to understand the sustainability aspect of it, how you compare it with the renewable energy, not just the fact that, they're going to charge you this amount of money. And that's really not what it's all about. It's about, what can we do to make an improvement? What can we do to help each other out? And what can we do to help out our earth and our environment? So, not just a conventional HVAC guy come in and is going to hold his thumb up from the curb and tell you it's a 4-ton house.
So Dave, I appreciate that testimonial. I take it that if Tom is interested in having you come and take a look and see what can be done to make his system function properly, you could just sign up and we could pass him along to you. Is that fair to say?
I'd be happy to stop over at his house and take a look and see what he has going on there and give him a recommendation for sure. Yeah.
Okay. And then I guess one other question that I would have for Tom is, how's your insulation and air sealing? Because that's a very important matter with heat pumps, to make sure that your house is it says too drafty. And so that's making me think that maybe some insulation and air sealing is needed there too. But I might be reading wrong there. There's a question here from Bill and Jill Schultz, Bill Altman and Jill Schultz. Any news about new incentives from the feds? There really wasn't much in terms of heat pumps other than the ground source heat pump incentive is being maintained at its current level. Not the incentive, the tax credit. That being said, we and many others are working to get more going on. Currently, there's no tax incentive for air source heat pumps at all. And tax incentives, while certainly better than nothing, are in often cases a kind of cumbersome and imperfect way of incentivizing things. Okay, so Tom's saying the house is very tight, been tested twice, rim wall insulation. All right, so it's just the heating system then. Yeah, long story short, the incentive that we need is something that anybody who has a building can use. And if you're a nonprofit or if you're on a fixed income and are not paying taxes, etc., a tax incentive really doesn't help you much. So we have some hope given how much the Biden administration has emphasized climate in their campaign and now in the inaugural speeches, that we'll be able to do something more ambitious. But with these things, I always wait until I see them.
Well, Adam, I think it's probably worth noting. I know Bill and Jill. I met them a couple of years ago. I believe. Maybe not. Maybe I'm thinking of someone different. But anyway, the Empower program for the LMI. I mean, that's basically the numbers that I've seen. When coupled with the LMI coupled with the New York State Clean Heat Incentive, the heat pump systems are the cost is basically next to nothing. Like the Empower incentives are tremendous, like $3,000 for every 10,000 BTUs of heat. It's like triple what the clean heat is. And the clean heat isn't. I mean, it's pretty significant on its own. So, I mean,
can you put those slides up on this up on the screen, Olivia? Maybe we'll just go through those real quick. And while we're doing that, Cheryl has asked, Dave, can you repeat the info about the tax credit and how much you can save monthly? The tax credit is available for geothermal. That's 23%. In terms of how much you can save monthly, that's really going to depend on a lot of specific factors. I don't know if you want to address that one, Dave.
Yeah, I mean, every house is different. It depends on what you're using for fuel currently. What the load is on the house, how much fuel you're consuming. Obviously, the more fuel you consume, the more opportunity you have to save. So, it's hard to say if you're burning natural gas, the savings are far, far less than if you're burning propane. What's the cost of propane? I mean, typically, a general conservative rule of thumb is if you're burning fossil fuel, you're going to cut your cost by at least half. So from your propane or fuel oil, I mean, that obviously changes as fuel cost goes up or down or so on and so forth. But the electric cost is fairly stable. So it gives us at least something to kind of consistent, a good starting, good reference point from a cost of operation standpoint. But yeah, I mean, the more you use, the more opportunity you have to save. As far as the tax credits go, yeah, I mean, geothermal gets a little more recognition, or has, but air source is really, I mean, from a residential standpoint, it's just much easier applied. It's more affordable. It's more versatile. It performs just as well. I mean, a lot of the geo numbers you see, what nobody tells you is, yeah, it's rated at a COP, a coefficient of performance of 5 or whatever, but that's at a 50-degree water temperature. So there's this big, everyone thinks it's a 50-degree water because the earth is 50 degrees, but it's a closed loop typically, and you're always removing heat from that closed loop. And that temperature, that water temperature is closer to 20 or 30 degrees, not 50. So those efficiencies that are published, they're not accurate for real world situations. So the efficiency comparison is far closer than what it's led to be. And I think as nice people like NYSERDA, they make these things more evident to people in government, they'll recognize the value. It's just far more pragmatic and to apply air source to a wide base of housing stock than it is for geo. And the geo, look, I love geo, don't get me wrong. And when applied, it's great. But this house I'm in here, like today, I mean, it's not really an option. I mean, you could put, I guess, radiant in, you'd have no cooling. You'd have to put some of those big fan coils they have in there. The other thing is here you've got big south facing windows. So Jeff here, when the sun comes out, he can turn his air source system off with a push of a button, actually from his phone, and instantly stop heating his house because of the solar gain of the windows. When you have radiant in the floor, it's going to keep giving off heat whether the house needs it or not. So, you have overheating, especially in high efficiency houses, right? So there's all these situations.
Dave,
that
I'm sorry,
good,
I got to jump in because we're very close to the end, and I wanted to get back to these slides, and also there's another question from somebody that sounds like she really needs help.
Yep.
All electric, budget of $200 a month. All thermostats and baseboards are failing. The first part of the question, I'm not sure what it is because there's a typo. So it's something of system cost. Cheryl, I don't know if you can either type or if you want to unmute and just ask your question. And while we're waiting for Cheryl, I can talk about the low and moderate income. Oh, there we go. Go ahead, Cheryl.
Can you hear me? I'm sorry.
Yep.
Yeah, I was trying to figure out what the geothermal tax credit was with 25% of the total cost of the installation of the system
23.
and 23%. And because it seems like when I did the math, if I put in a double header with a third head optional, that it'd be about 13,000 to do a heat pump like the air heat pump. But I was curious if the geothermal cost would come in about the same after tax credits. And then our house with the two of us, our total budget is average of $200 a month, and it's an all electric house. So I'm just kind of curious how much we could save that would go toward paying for the cost of the system.
Well, it would be,
so you're heating with electric.
Yeah,
I'll just
electric.
say one thing, that the geo estimate is very likely to be higher. Dave, why don't you briefly answer, and then I want to get into these slides so you can see, Cheryl and others here, what incentives are available for low and moderate income folks. And they've extended these a bit, and I want to get that before we close.
Yeah, how much do I owe you, Lou? How many hours?
I'm sorry?
Oh, I'm sorry. I have to mute myself. I'm sorry.
No worries. Go ahead, Dave.
So Cheryl, whatever your cost of heating is, you're going to be less than 1/3 of that with the air source system. The other thing is with the quote that you received, two zones with an option to add a third. Not really the greatest, not always the greatest solution. Maybe if it's a future addition or something like that. Using 2 zones, first of all, doesn't give you full output of the unit because of some restrictions in the expansion valves. We don't need to get into all that. But the other thing is, when they quoted you a system, did they give you the incentives, right? Typically a triple zone system, the Mitsubishi triple zone Hyperheat 3C30 makes 28,600 BTUs at 5 degrees Fahrenheit. So did they give you a $2,860 incentive off of that price they gave you? If not, then it wasn't a correct whole house system design. So there's a lot of things you know, you got to get more than one look at it and really dig into the nuts and bolts of it to get an accurate quote. If it's something you're interested in, we can certainly come out and take a look and give you a correct design with a good cost.
I would like somebody to come back out and look at it. I did have one of your fellows came out, and I think actually I misspoke. I think it was 3 heads for Mitsubishi, and then that was after the rebates and incentives. But I wanted to compare that to geothermal, and I just never closed the loop. And then this winter we're halfway through it, and my thermostats are all crap, and a lot of the baseboards aren't working correctly anymore. So, you know, I'm looking at, do I want to go with radiant heat? We have a 3/4 our crawl space. There's too many details, but we have a crawl space, and it's a 50-year-old house. And I think that we could do better with energy here, but we don't plan to be here more than 5 more years.
Yeah, I mean, Cheryl, because you have no distribution system, the cost of you doing geo there is going to be astronomically higher than air source, because you have to put in, you'd have to pipe the whole house. You know, you have electric baseboard, so you'd either have to duct it or pipe it. And then you're talking about water to water, which again decreases efficiency of the geothermal, because you haven't captured the electrical consumption required by the pumps to circulate the water through the heat exchanger, you know, the plate exchanger, and the pumps to pump throughout the house and all that type of thing. So you'd be way more to do a geo for sure. You know, if you had an existing ducted system, you know, that might be a different story. It would be more, but not as much, but it would be far more to do geo in your situation.
So
our house is like it's like 1.5 stories, so a lot of the heat just kind of goes up to the balcony area. So yeah, I kind of came to the same conclusion, but I would like to have somebody come back out, and I'll call your office. I don't want to monopolize your last 5 minutes of your presentation.
No problem.
Thank you.
Cheryl. Go ahead,
Thanks,
Adam.
Cheryl. Yeah, so very quickly, there's an extended eligibility for the assisted home performance with Energy Star program. So if you see the slide here, depending on your household size, you can be eligible for 50% off of project costs, up to a total of $5,000 for single family, $10,000 for 2 to 4. And we know that's going to continue at least through the end of March. It'll probably go later, but until it's in writing, we don't know. And now I want to talk about what Dave was mentioning earlier with the heat pump study. Can you go to the next slide, Olivia? Okay, so the Empower program, there's 2 aspects for this. And this is the first piece. You can see again, the household size income limit here. If you are on HEAP, if you are receiving TANF or similar programs, you qualify for this. You can get free assessment and efficiency improvements, and the maximum award is increased to $10,000 until March 31st. Next slide, please. This is the last slide. So the news that Dave was talking about, for folks who have incomes under 80% of area median income, there's very generous incentives available now for a limited time, basically until they spend the $5 million. You cannot be heating with natural gas, and your home would have to be insulated first. This is a stackable incentive. So the incentives that were mentioned earlier by Dave from NYSEG, and these are additional. So we're here to talk air source. For air source heat pumps, per 10,000 BTU, there's an incentive. If you are below 60%, again, if you qualify for HEAP and other similar programs, $3,000 per 10,000 BTU. For Empower, if you're a little bit, have a little bit higher income, if you're up to 80%, it's half that. Dave, I know there's nothing like a really typical house, but in terms of BTUs, 30 to 40 is fairly common. Is that fair to say?
Yeah, we see them 25 to 75, but I would say most houses are, between
so you can do the
30
math.
And 50. Yeah.
30,000 BTU, that's $9,000 off. 40,000 is 40,000 is 12,000 off. And so, yeah, these heat pumps, particularly for low income, for Empower eligible, come in basically free. So if you think you might qualify for that, definitely don't wait around. Again, we're hoping this is going to last for a while, but this is a very attractive incentive, obviously. So get your free incentive. I'm being asked a question, is propane considered natural gas? No, not in terms of service cost. It's not. So propane tanks are another expensive form of delivered fuel like heating oil. I got my Geo system because of the expense of heating oil. Number 3, propane is also costly. So I'm going to have to wrap us up here because we are almost 5 minutes after the time we were supposed to end. But I'm very excited by all the interest and the participation. That's fantastic. I want to thank Jeff for being so generous to allow us into his family's home, and as always, thank our stalwart air source partner, Dave Tierno of AirSource LLC, for all the work that he does. And we are going to be starting a new series sometime either next month or early in March. We'll have more tours such as this. We're going to have more programs focused on folks who are low and moderate income. And I'm hoping we'll be having some small commercial stuff, but we got to figure a few things out first. So thanks very much and have a great day, everyone.
Thank you.